you're going to be finding some arc measures now. Let's see, arc measures and length. Arc measures and length. Okay, so look at the picture there on the top of page 708. It says female participation in sports, and it's a big pie graph. And it looks like a pie, and it's got a bunch of different points around the pie, A, B, C, D, E, and F. You got point A, B, C, D, E, and F. Alright, refer to the circle graph, find each measure, and you're asked to find the measure of arc CD. Okay, the measure of arc CD. So you're trying to find the measure of this arc right here, C to D. Well, look at the piece of the pie that corresponds to that arc. And the piece of the pie that corresponds to that arc is volleyball, right? It says volleyball, and it says 18%. Alright? So, female participation in sports. What this means is that of the people surveyed, of the females surveyed, 18% of them play volleyball. Well, what you have to do now is, since 18% of them play volleyball, 18% of this arc, 18% of this circle represents volleyball. Alright? And a circle has 360 degrees in it, doesn't it? So what you have to find is 18% of 360. So you take this corresponding percentage, you take 0.18, and you multiply it by 360. Okay? And that will give you the measure of that arc. So in your calculator, take your 0.18 and times it by 360. And you should get 64.8. Now, this 64.8 is going to be in degrees. Alright? Volleyball in this pie graph represents 64.8% of this entire circle. Make sense? Whatever the corresponding pie takes up of the circle is what you multiply by 360. And while you're still working on that same pie or pie chart, they are asking for the measure of arc BC. Alright, the measure of arc BC. That's track and field. Why didn't they change it? The measure of arc BC. That's 18% again. So you don't do anything different. The measure of arc BC is also 64.8 degrees. Okay? Let's find the measure of arc EF. The measure of arc EF in this picture. Arc EF is this, we'll call it, make it this blue arc right here. From E to F. And that portion of the pie takes up 14%. So you take 0.14 and you multiply it by 360. And that's equal to 50.4 degrees. Okay? So when you're finding arc measures in these pie charts, or in any type of problem, find the percentage that corresponds to that arc and multiply that by 360. Bottom of page 708. Use arc addition to find the measure of arcs. So you've got this picture. Here's the diameter. Here's another diameter. That's not very accurate, but that's going to have to work. Alright, it's got this angle, has this symbol on it. I know it doesn't look like 90, but that's what you got to deal with. And we got 63 right here. And it says to find each measure in circle F. This is circle F. You need to measure the measure of arc AED. AED. And here's our points. We got A, B, C, D, and E. Okay, kind of like yesterday. What I would suggest that you do first is you start filling in these missing angle measures. Okay, first of all. So look, you guys remember vertical angles? Angles formed by two intersecting lines. If this angle right here is 63 degrees, then what's the angle opposite of it? Right there. That's 63 as well. Okay? Now look at this. Do you see the 63 and the one next to it? Those two form a straight line, don't they? Makes them a linear pair. Linear pair, supplementary. So 180 minus 63 gives you this angle BFA. So 180 minus your 63, 117 degrees. Okay? This angle right here is, excuse me, 90. So you got this one little angle left. All right? That one little angle left, again, the 63, the 90, and this little angle all form a straight line. They're like a linear group. So they all need to sum 180. So 180 minus 90 minus 63 is this last little angle. 27 degrees. So those are all in degree measures, and they're asking you to find the measure of arc AED. AED is right here. It goes from A to E to D. So AED, this arc, is equal to the 63 plus the 90. 63 plus 90. It's 153 degrees. Second question, the measure of arc CE. The measure of arc CE. And C to E would be right here in blue. Starts at C, ends at E. So that's a 90 plus a 27. And that's 117 degrees. How many colors I got left? The measure of arc ADB. The measure of arc ADB. A through D. Okay, look at this. Starting at A, going all the way around through D, and then ending over here at B. It's a big arc, isn't it? It's a big, major arc. You could either add up 63, 27, 90, and 63, couldn't you? Or what else could you do? Yeah, you could take 360 and subtract the 117, and it's going to save you a little bit of time. So 360 minus the 117 is 243 degrees. That making any sense? Okay. Look at the top of page 709. Top of 709, arc length. And let me think of the best. Arc length. The length of an arc of a circle. Arc length. Here's the best way to do this. You're going to find the measure of the central angle. You're going to divide it by 360. And you're going to multiply that by the circumference. And circumference of a circle, remember, it has two formulas. It's got 2 pi r, or it's got pi times diameter. Those are the two formulas to find the circumference of a circle. So these arc length problems can become like sometimes a couple steps involved. So here's the first example you got. We got this picture. Here's the center of this circle. We got X, Y, and Z. This central angle is 75 degrees. This radius is 4. Find the length. You're asked to find the length. Different from measure of. Find the length of arc YZ. Find the length of the arc YZ. You're looking for the length of this. Different from measure of. Measure of is where there's the lowercase cursive m in front of the arc. This says find the length of the arc. So this is the formula that you have to use. So look, the length, arc, YZ, is equal to the central angle. What's the central angle that corresponds to YZ? It's that 75 degrees. So 75 over 360 times. You're given the radius, so use the radius formula. 2 pi times 4. Okay? You can do all of this in your calculator. If you take your calculator, 75 divided by 360 times 2 times pi button times 4 and hit enter. And I got 5.236. Make sure you plug that in your calculator to see if you get the same number. You get that, Andrew? And does everybody see where those numbers came from? Central angle divided by 360 times 2 times pi times the radius. All right, so let's try one more of those. We got a 10. When this 10 is right next to the center of the circle, it's the diameter. You got a 130. You've got an X. We're looking for the length of Z to Y. So this is a Y, this is Z, and we need arc Z, Y. Wonder why they put the X in there. You don't even need it, do you? Alright, so central angle, which is 130, divided by 360 times. Now, if they give you the diameter, just use pi times diameter. Alright? So, 10 pi. So this arc length, Y to Z, or Z to Y, 130 divided by 360 times 10 times pi. Y'all get 11.345. Okay? You guys get the idea? Central angle over 360 times circumference. Alright? Arc length. Central angle divided by 360 times the circumference. Okay? It's different from arc measure, so be careful when you're reading the instructions. Alright, so here's some practice for you today. On page 710 again. Page 710. Six through 11. 6 through 11. And problem 24. And 24's got 3 parts to it, so it's 24A, B, and C.